Good day, class. Today, I will be guiding you through the basic computations that you will be encountering in your nutrition laboratory component. Starting with the BMI or your body mass index, followed by your DON or your degree of nutrition. Next, you will also be learning about the ideal body weight or your desirable body weight. You will also learn about your total energy requirement or your TER, as well as the TER distribution in terms of carbohydrates, proteins, and fats. Lastly, you will also be learning about the recommended energy and nutrient intake. Before we proceed to the lesson proper, please familiarize yourselves with the different conversion values. 1 kilogram is equal to 2.2 pounds. 1 meter is equal to 100 centimeters. 1 inch is equal to 2.54 centimeters, and 1 foot is equal to 12 inches. First, we have our body mass index or our BMI, which is the most commonly used nutritional value or nutritional computation in the hospital setting. This is a measurement of a person's weight with respect to his or her height. It is more of an indicator than a direct measurement of a person's total body fat. So as you can see here in the left corner, you can see the formula of your BMI. So we have your weight in kilograms to be divided by the height in meters squared. Okay, so here you have your TER and TCR. So again, your TER stands for your total energy requirement, while your TCR stands for your total caloric requirement. There are many ways to compute for your TER, and you will be learning about those different ways in the next few slides. But first, let's discuss in more detail about our BMI. Okay, so our BMI has this classification. According to the World Health Organization, a BMI of below 18.5 is considered underweight. A BMI of 18.5 to 24.9 is considered normal. A BMI of 25 to 29.9 is considered overweight. And lastly, a BMI of over 30 is considered obese. Now, by Asia Pacific standards, as you can see on the right side of this slide, you can see some differences. Okay, sorry for that. An airplane just passed by. Okay. So the main difference here in the Asia Pacific standards of BMI is that it has two classifications for obese. Okay, so obese 1 corresponds to a BMI that's between 25 to 29.9, and for obese 2, that's for a BMI of over 30. Okay, so since we are Filipinos, we fall under the Asia Pacific standard. Okay, so if and only when the BMI of a patient is abnormal, that's the only time that we will be using the TER column. Okay, so here is a sample problem. Okay, so we have a 26-year-old female nurse with a current height of 4 feet and 11 inches with a weight of 55 kilograms. So in this problem, we have the following given information. The height, which is 4 feet and 11 inches with a weight of 55 kilograms. So we're going to start by converting the height of the nurse to meters. Okay, we start by converting the feet to inches. followed by converting the inches into centimeters, and lastly, converting the centimeters to meters. Okay, so in the next slide, you will see a more detailed version of this solution. Okay, so here is a step-by-step process as to how to compute for the BMI. Okay, so again, we have conversion of feet to meters, this part, and then we convert the inches, okay, inches, okay, into centimeters, and then lastly, centimeters to meters. Okay, so now we have a height of 149.86 centimeters. Okay, so if we compute for the BMI, okay, so we start with the weight. The given weight is 55 kilograms. And then we divide it to the height of the patient in meters, but then we have it squared. Okay, so we would arrive with the answer of 24.44. Now, if we base it to the BMI chart, according to the WHO, since this is normal, okay, so we can consider this as, we consider this normal. Okay, so it falls within the range of 18.5 to 24.9. Okay, that's normal. Okay, I can give you a few seconds to analyze this one. Okay, or you may opt to pause the video so that you will see the solution, okay, according to your own pace. Okay. Again, you may use the BMI or degree of nutrition for adjustments in TER or TCR. Okay, that is if your patient showed an abnormal BMI. Now, there may be individuals who are conscious about the upper and lower ends of their BMI range. Okay, so we can also compute for both the lower and upper ends of the normal BMI range. Okay, so to compute for the lower end of the weight range, we multiply the height squared by 18.5. And then as for the upper end of weight range, we multiply again the height squared times 24.9. So itong 18.5 and 24.9, these are constant values. Okay? So here you can see the example. Okay, so with a height of 4 feet and 11 inches, when converted to meters squared, you get an answer of 2.25. So you're going to multiply 2.25 to 18.5. So the lower end of the BMI range of the patient or of the client is 41.63 or 42 kilograms. Now, as for the upper end, again, you're going to use the height in meters squared. So we have again 2.25 times 24.9, itong constant for the upper end. So you will arrive with an answer of 56.03 or 56 kilograms. Now that is the upper end of the weight range according to the person's BMI. Okay, so meaning for the person to have a normal BMI measurement, his or her weight should be 40 kilograms to 56 kilograms. Okay, ito po yung normal weight range na dapat ma-maintain ni patient. Okay, so next we proceed to your desirable body weight, okay, or your DBW. Okay, it's also known as the ideal body weight or IBW. This is the optimal weight associated with maximum life expectancy for a given height. Now, before the use of BMI to quantify obesity, TBW above 20% of IBW was defined as being obese. So, ito yung standard na finalo before the use of BMI. Okay, so we have different methods of estimating the desirable body weight according to a client's age. Okay, so here we have estimating desirable body weight for both infants and children. Okay, for infant, okay, so the desirable body weight will be computed in this manner. So age in months divided by 2 plus 3. Okay, so the example here is a 7-month-old infant. Okay, so to compute for the DBW, okay, so we have 7 divided by 2. Okay, so that is constant. Okay, constant po ito. Okay, so divided by 2 plus 3. Okay, so you have 3.5 plus 3. So the desirable body weight for 7-month-old infant is 6.5 kilograms. Now, as for children, again, there is a constant value to be used. You just have to be familiarized with the formula. Okay, so to compute for the desirable body weight in children, we have the age in years times 2, and then we add 8. Now, for example, we have an 8-year-old child. Okay, so to compute for your DBW, we multiply 8 times 2 plus 8. So 8 times 2 is 16, and then we add 8, another constant. So the normal or the desirable body weight rather for a child, for an 8-year-old child is 24 kilograms. Okay. So so that's basically how you do your DBW measurement or DBW computation. Next, we also have a method of computing desirable body weight using the Tannhauser method. Now, what are the things to remember? First of all, you have to measure the height in centimeters. Next, you are going to deduct from the factor of 100. And then the desirable body weight obtained applies to Filipino stature by taking off 10%. So how are you going to solve for this one? You're going to see in the next few slides. Okay, so your Tannhauser method is also known as your Broca's index. So again, same problem. A 26-year-old female nurse with current height of 4 feet and 11 inches and a weight of 55 kilograms. Again, you're going to convert the patient's height from feet to inches and then from inches to centimeters. Okay, so for you to have a more detailed view of this solution, you're going to solve for it this way. Okay, so after converting the height in centimeters, you're going to deduct from the factor of 100. Okay, so let's say you arrived at the answer or at the height of 149.86. So you're going to deduct 100. Okay, so 149.86 minus 100, that's equal to 49.86. Next, to compute for the desirable body weight, you're going to take off 10%. Okay, so 49.86 times 0.10, that's your 10%. That's equal to 4.986. Okay, and then you're going to deduct the first and the second values. Okay, so 49.86 minus 4.9, 4.986, you will arrive with the answer of 44.87. So the patient's ideal body weight is equal to 44.87 kilograms or 45 kilograms. So we have to follow rounding off rules for the final answer. Okay, so I'm going to give you a few seconds to analyze again this solution, or you may opt to pause the video before we proceed. Okay, once again, sorry, car passed by, just in case you heard that on your end. Okay, so next computation is your degree of nutrition or your DON, DON. Okay, so for your degree of nutrition, we start with the obese classification. So a person is considered obese if it's over 120% of his or her ideal body weight. So to compute for your TER, we deduct 500. For an overweight person, that would mean 110 to 119% of his or her ideal body weight. So for that, we deduct 250 for the TER. For normal, which is 90 to 109% of his or her IBW, no computations at all. And for underweight, as you can see, we have first, second, and third degree. Okay, so for first degree, it's 80 to 89% of his or her IBW. Okay, so that would indicate mild risk of malnutrition. For the second degree, that's 71 to 79%. That's considered moderate risk of malnutrition. So for both first and second degree, we add 250 to get the TER. Lastly, third degree, the third degree classification means 70% and below, and that's for severe malnutrition. So for this, we add 500 to get the TER. This is commonly used in the community setting and especially useful for pediatrics in determining malnutrition. Although this can also be used in adult deduction, and addition will be used in TER once result is not normal. Okay, so here is a sample computation for the degree of nutrition. Okay, so we start with the actual weight times 100 to be divided by the IBW or the DBW. Okay, so we have the given data. Okay, so actual weight of the patient is 55 kilograms, while the IBW of the patient is 45 kilograms. So 55 over 45. Okay, so times 100. We have 1.22, okay, times 100. Okay, and that's equal to 122.22%. Now, if you look at the degree of nutrition table, okay, so the patient's DON falls under obese. Okay, that's greater than 120%. Okay, again, if you look at obese here, any degree of nutrition that is greater than 120% is corresponds to obese. So therefore, the patient's DON is obese. Again, you may use BMI or degree of nutrition for adjustments in TER or TCR. Okay, so it's a matter of properly computing as well as rounding off correctly. So basically, the rule of thumb when it comes to rounding off, you have to round off to the nearest value or to the nearest amount divisible by 50. Okay, so next we proceed to our TER, our total energy requirement, as well as our TCR, our total calorie requirement. Okay, so we have to round off the final TER or TCR to the nearest 50, or a number that can be divided by 50. So we have different methods of computing for TER. We start with computing for TER of infants. So the formula for computing TER of infants is a compute for the K per day. Okay, so example, in a baby that's 8 months old. Okay, so we are going to first compute for the desirable body weight. Okay, so again, 8 months. So 8 divided by 2 plus 3. Okay, so we start. Okay, so 8 divided by 2, that's equal to 4. And then plus 3, that would give you a desirable body weight of 7, 7 kilograms 7 kilograms. Now we have to consider this reference. Okay, so in computing for the TER, for a baby age 0 to 6 months, that would be equal to 90 kilocalorie per kilogram of desirable body weight. Now, for a baby that's age 7 to 12 months, that would give you a TER of 95 kcal per kilo desirable body weight. So if you compute for when you compute for the TER, okay, so since your baby is 7 months, okay, so you're going to make use of 95. Okay, so TER, okay, 95 kilocalories per kilograms of desirable body weight. So we start with 7 kilograms times the 95. Okay, so you will arrive you will arrive at 665 or 650 kcal per day. Okay, so you have to base it on the uh, last two digits. Okay, so 65 is closer to 50. Okay, so that is why our rounded off value for the TR is 650 kilocalories per day. Okay, I'm going to give you a few seconds to analyze this solution, or you may pause the video, okay, before we proceed. Okay, there is a tip in rounding off. Okay, so for 25 and above, okay, we're going to add 50. You're going to add 50. Okay, so for example, for 125, this will be 150. Now, what if the last two digits are 24 or below? So, for example, 124, this will be rounded down to 100 instead. Okay, so take note of this one. Okay, next we have another method of estimating TER, but this time for children. Okay, children age 1 to 12 years old, and also for adolescents age 13 to 18 years old. Now we have this age range. Okay, so kindly familiarize with yourselves with this one. Okay, I just had this inserted on the next slide for your reference. Okay. So let's say, for example, you're going to compute for the TER of a 4-year-old girl with a 16 kilogram body weight. Okay, so first we are going to compute for the desirable body weight. So age in years, okay, so 4 times 2 plus 8. Again, you're going to follow the constant, okay, constant formula. Okay, so 4 times 2, that's 8. So 8 plus 8 is equal to 16 kilograms. So a 4-year-old girl is has a desirable body weight of 16 kilograms. Okay, so for you to compute for the TER, you're going to solve it in this manner. Okay, so we're going to make use of the table. Okay, so for for a weight of 16 kilograms, you're going to use 72 kilocalories. Why? You have to look at the table. Okay, so for a girl, okay, so in this example, the girl is 4 years old, and her, sorry, okay, and then, her TR, okay, and then her kilocalorie per kilogram desirable body weight is 72. Okay, so this is what you're going to use in computing for the TR. Okay, so we have 16 times 72. So that would bring you to an answer of 1,152 kilocalories per day, or simply round it down to 1,150 kilocalorie per day. Okay, so you have to make use of the table for this one. Okay. Next, we proceed to the TER for a teenager. Again, the age range for a teenager is 13 to 18 years old. So let's say, for example, you have this problem. You're going to compute for TER of a 15-year-old boy who stands 5 feet in height. Okay. So again, you're going to do the basic conversion. So 5 feet is going to be converted into inches and then into centimeters. Okay, so 5 feet times 12 inches is 60 inches. So if you want to convert that to centimeters, you're going to multiply 60 times 2.54. Okay, so you will arrive at an answer with an answer of 152.4 cms, but then again, you're going to subtract 100. Okay, after subtracting 100, you have an you have an answer of 52.4. Now you're going to multiply that by 10% because you're going to deduct that one. Okay, so 52.4 minus 5.24, that will lead you to 47.16 or 47 kilograms as the teenager's desirable body weight. Now again, you're going to look at the table. Okay, so we know that the child is, we know that the adolescent is a boy, it's a male. Okay, so we're going to look at the table, okay, once again. So the the patient here is 15 years old, so we're going to start by looking at the age range. And then for sure, okay, we have this here. Kilocal per kilograms desirable body weight. So nandito po siya. Okay? So this is the value that you're going to multiply against the computed desirable body weight. Okay, so 56 kcal per kilogram times 47 kilograms of your patient's body weight, that's equal to 2,632 or 2,650 kilocalories. Okay, so you may take a few more seconds or even a minute to analyze this solution, or you may pause. Okay, the usual thing. Okay. Next, we have another method of computing TER. Okay, sorry for the mild interruption. Okay, so going back to another method of computing for your TER, we have computation according to PA or physical activity. Okay, so we have different classifications of activities. Okay, so on number one, in bed but immobile. So that would give a kilocalorie per kilogram of 27.5. Okay. Next, we have sedentary or very light work. So that's equal to 30. Okay, so professions under this classification include secretaries, clerks, typists, especially those using electric typewriters, administrators, cashiers, and bank tellers. Next, we have light, a light activity, which is equal to 35. So professions under this include teachers, nurses. Although medyo disclaimer siya konti because there is no way that a nurse's work is light. But however, because this is based on an old reference, so dito po talaga muna nakalagay si nurse. Okay? Next, we have students, lab technicians, and housewife with maids. Next, we have moderate active. So that would give a kilocalorie per kilogram of 40. Now, professions or people who fall under this include housewife without maid, vendors, mechanics, jeepney drivers, and car drivers. And lastly, we have those individuals who are classified as very active in terms of physical activity, which is equal to 45. They give off kilocalories. They give off 45 kilocalories per kilogram. So professions or people that fall under this include farmer, laborer, especially mga cargador, key coal miners, fishermen, and heavy equipment operators. Okay, so let's say, for example, the weight of your patient is 50 kilograms. So to compute for the TER according to his or her physical activity, you're going to refer to any of these. Okay, so in this example, okay, so your patient is a nurse. Okay, so the patient's weight is 50 kilograms. So the patient's physical activity would fall under light kasi nurse siya according to the problem or according to the situation given. So we have 35, okay, 35 kilocal times the patient's weight of 50 kilograms. That would give a TER of 1,750 kilocal per day. Okay, so next, on the next slide, you will see another table, okay, describing physical activity levels and values by occupational work intensity. Okay, so according to the new reference, this is the latest. So instead of using PA, they use PAL instead, your physical activity level. Okay, so you may pause the video to read this, okay, to digest the information in this table before you proceed. Okay, so here we have a sample problem. Okay, so a 26-year-old female clinic nurse with current height of 4 feet and 11 inches and a weight of 55 kilograms. Okay, so we're going to compute for the patient's TER. Okay, so we have this formula. So the TER is equal to ideal body weight in kilograms times the physical activity level. Now for this example, we are going to use the dawn. Okay, so the ideal body weight for this patient is 45 kilograms, okay, after computing. So we're going to multiply that by 35 kilocalorie per kilogram. Now according to the table, next, we are going we're going to arrive with an answer of 1,575 kilograms. So next, we're going to deduct 500. So why are we going to deduct 500? This is because the patient falls under the category of obese according to the degree of nutrition. Okay, so we can go back to the table, okay, from a few slides back. Okay, so go back to slide number 15. Okay, so the BMI of the patient is 24.44. So the patient falls under the obese, DON. Okay? Okay, so because of this, we are going to deduct 500. So 1,575 minus 500. You will then arrive with an answer of 1,075 kilocalorie. Then you're going to round it off to 1,100 kilocalories. Okay? Again, you may pause the video at this point to analyze the solution of this problem. Okay. Again, here are guidelines in rounding off for TER and also for the TCR. We round off the final TER or TCR to the nearest 50 or an amount that can be divided to 50. You may use the BMI or degree of nutrition for adjustments. So here are some examples to help you be guided. Okay, so for example, 1,632 will be equal to 1,650. Why? Because 32 is more than 25. So if it's more than 25, we're going to have it rounded off to 50. Hence, 1,650. In the second example, you have 2,785, which you can round off to 2,800. Okay, because it is closest to 2,800 already. Next here, 1,624 will then be rounded down to 1,600. Why? Because you're going to look at the last two digits. Okay, so this is 24. Okay, less siya. This is below 25. Okay, so that is why it's going to be rounded down to 1,600. Okay, next, you're going to recheck the final answer of the TER. Okay, so with a TER of 1,075 kilocalories, you have to check if it is more appropriate to round up to 1,100 or round down to 1,050. Okay, so step one, let's start with 1,075. So if you divide it by 50, it's equal to 21.5. So you're going to round off to 22. You're going to compare this to the answers in step 2 and step 3. Okay? So next you're going to divide 1,100, sorry, by 50. Okay, that would give you an answer of 22. And then step 3, 1,050 divided by 50, that's equal to 21. So the final answer, okay, will be 1,100. Okay. Next, we proceed to the TR distribution of carbohydrates, proteins, and fats. Okay, so I just want you guys to be familiarized with the percentage values of each of the macronutrients. For carbohydrates, the acceptable macronutrient distribution range is 55 to 75% of the TER. For proteins, it's 10 to 15% TER. And for fats, it's 15 to 30% TER. Now, for clinical conditions and for children and other age or physical groups, there can be modifications in the distribution of carbohydrates, proteins, and fats. Okay, so these modifications should be made accordingly. Now, since we are Filipinos, okay, so for a normal adult Filipino, okay, I want you guys to remember the percentage that you will follow for carbohydrates will be 65%. For proteins, it's going to be 15%. And lastly, for fat, 20%. Okay, ito po yung gagamitin natin na percentage value for normal adult Filipinos. Okay, so again here, I just made a bigger slide for this one based on the notes on the previous slide. Okay, so for your reference, again, carbohydrates is 65% of TER, proteins is 15%, and fats is 20%. Okay, so once again, remember in rounding off of carbohydrates, proteins, and fats, you're supposed to round off these macronutrients to the nearest 5 or divisible by 5. Okay, so we have an example for this one. Okay, before we proceed with the example, I want you to be familiarized with this. Okay, so this is with regards to the distribution of calories. 1 gram of carbohydrates is equal to 4 kilocalories. 1 gram of proteins is also equal to 4, while 1 gram of fat is equal to 9 kilocalories. Okay, so with an additional alcohol, okay, so 1 gram of alcohol is equal to 7 kilocalories. But here, kindly focus on proteins, fats, and carbohydrates. Okay. Okay, so how do you distribute the TER of carbohydrates, proteins, and fats? Okay, so this is what we call your macronutrient distribution. Okay, so the problem here again, a 26-year-old female nurse with a current height of 4 feet and 11 inches and weight of 55 kilograms. Your computed TR is 1,100 kilocals. So we're going to use the percentage value, okay, according to normal adult Filipino. Okay, so carbohydrates is 65%, proteins is 15%, and fats 20%. So how are you going to compute for this one? Okay, so for carbohydrates, you're going to start with your TR of 1,100. 1,100 kcal times 0.65, that's your 65%, that's equal to 715 kilocalories. Okay, and then you're going to divide the 715 kilocalories into 4 or by 4 rather. Okay, so you will arrive with an answer of 178.75 or 180 grams when you round it up. You will do the same process with your proteins and fats. Okay, so protein, 1,100 kilocalories times 0.15, or that's your 15%, you will arrive with an answer of 165 kilocalories. So again, that 165 kilocalories will be divided by 4, and that will be equal to 41.25 or 40 grams. Okay, 40 grams of protein. Lastly, for fat, again, same process. 1,100 kilocalories times 0.20. Okay, that's 220 kilocalories. Okay, and 220 kilocalories will be divided by 9. And you will arrive with an answer of 24.44 or 25 grams. Okay, so for you to double check, okay, so the amount in kilocalories for carbohydrates, proteins, and fats, when added, should arrive to the total TER. Okay, so here, 715 plus 165 plus 220. Okay, that's 100. That's 1,100. Okay, get your calculators if you want to solve for yourselves. Okay, again, 715 plus 165 plus 220. Okay, that's equal to 1,100 kilocalories. Okay, next, this is your computation for your recommended energy and nutrient intake, or your RE&I. Okay, so after arriving, okay, at your number of kilocalories, again, you're going to divide it the number by the number of kilocalories per macronutrient. Okay, so for your RENI is basically, okay, so in one day, your patient's TER is 1,100 kilocalories. Ito lang yung pwede niya ma-consume. And for the patient to achieve or reach this, these are the amounts of the respective macronutrients that he or she must take in order to achieve this TER. Okay? So for carbohydrates, you have 180 grams. For protein, we have 40 grams. And then for fats, we have 25 grams. Okay, so you may pause this part of the video for you to analyze how to solve for the RE and I. Okay? Okay, so now you have reached the last part of the discussion. Okay, so I will consider this as individual seat work and also as proof of your attendance for this morning session. For 2E particularly. Okay, so you are going to compute for your own energy and energy requirement based on the nutritional assessment tool. Okay, so first you're going to compute for your BMI. followed by your DON, and then your ideal body weight, plus your low range and high range, okay, of your BMI. Next, you're also going to compute for the TER using the DON. And then lastly, compute for the distribution of carbohydrates, proteins, and fats. And you're also going to illustrate, or you're going to present the amount of carbohydrates, proteins, and fats according to the RENI. Okay, so consider this po as graded seat work plus attendance. Okay, for section 2G, you may do this during the your laboratory session on Friday.